Resins for polyurethane coatings. The name is due to the urethane linkage which is formed when an isocyanate is reacted with a hydroxyl group. There are many varieties of polyurethanes with different properties. Isocyanate group is reactive at medium and room temperatures, reacting exothermically 40 kJ per mole with many groups containing active hydrogen atoms like alcohols, amines, phenols, amides and water. The reaction initially produces an unstable carbamic acid RNHQ, which decomposes to a primary amine and carbon dioxide. This reaction is exploited in the case of urethane foam formations and avoided in the case of urethane coatings. Hence, systems to be reacted with isocyanates for coating purposes should be dehydrated and low moisture content urethane grade solvents should be used. Polyurethanes are capable of providing very tough finishes with excellent resistance to weather, corrosion, abrasion and chemical attack. Films can be made flexible enough to coat rubber, leather, plastics and hard enough for metals and concrete. They are made from isocyanates with free reactive NCO groups. The main isocyanates widely used are toluene diisocyanate (TDI) aromatic, followed by hexamethylene diisocyanate (HMDI) aliphatic. Diphenylmethane diisocyanate (MDI) aromatic, and isoferone diisocyanate (IPDI) aliphatic are used to a comparatively lesser extent. The widely used three main types of PU systems, namely urethane oils, two-pack systems and moisture-curing types, are discussed next. Urethane oils. In urethane oils, the concept is using TDI to increase the hardness and abrasion resistance of drying oils. They are prepared by reacting glycerol penterythritol with linseed, soya oil at high temperatures to form partial esters containing free hydroxyl groups. Then the mass is cooled and TDI and solvents are added at lower temperatures. Amount of TDI added is close to the theoretical NCO/OH ratio to make sure that no free NCO groups are remaining. Several brands of urethane oil are available in the market. They dry by the oxidation or heat to form tough and durable films. But the film properties are inferior to the other two types of PU. Two-pack systems. The most popular and widely used two-pack systems are based on hydroxyl functional resins and isocyanate adducts. They cure at ambient to provide a tough solvent-resistant film. The hydroxyl functional resin may be an alkyd, polyester or acrylic polyol. The isocyanate adduct may be an aromatic 1-toluene diisocyanate (TDI) or an aliphatic 1-hexamethylene diisocyanate (HMDI), which is made as an adduct in alcohols or phenols such as trimpolol propane, propylene glycol etc. to make isocyanate-terminated prepolymers. In these two-pack systems, pigments and additives are dispersed in the hydroxy-functional polyol resin and given as component I or A. The component II or B is the hardener containing the isocyanate adduct as described above. These are mixed at the time of application as per the ratio given by the manufacturer, and the resultant ambient cured film like epoxies is a tough one resistant to solvents, many chemicals and corrosion. Among the alkyd polyols, widely used one is a castor oil alkyd polyol. Castor oil, which is made up of mainly triglyceride of ricinoleic acid, is subjected to transesterification with polyols such as glycerol, and the alkyd polyol is based on castor oil. Films formed by this polyol have excellent resistance to water and weather. Polyols prepared by a similar process with drying oils such as linseed, oiticica and soya are also used in making uralkyds. They are used for wood finishing. Polyester polyol-based pus are used for high durability transport finishes, marine and aircraft coatings, and for coating plastic automobile parts. In the case of acrylic polyol, a functional monomer like hydroxyethyl acrylate (HEA) or hydroxyethyl methacrylate (HEMA) is introduced into the polymeric chain of the polymer, which is the reactive site with the isocyanate in the hardener NCO, a reaction at ambient conditions. Acrylic polyol-based pus find application in car finishing and refinishes, appliance finishes, and for corrosion protection in industrial applications. They are excellent as an UV-resistant topcoat to protect the epoxies from direct sunlight when cured with an aliphatic isocyanate HMDI. That is why most of the multicoat protective coatings contain epoxy primer, epoxy undercoat, and a PU topcoat of an acrylic polyol with an aliphatic isocyanate. The special outstanding qualities of these types of urethane coatings are abrasion resistance in addition to solvent, chemical and corrosion resistance. It can be reasonably claimed that no other coatings available have such abrasion and impact resistance properties. Hence, in addition to corrosion and UV resistance, they make excellent floor and deck coatings. Moisture-curing polyurethanes. The principle behind this type of coating is that isocyanate adducts are formed with polyether triols and diols with excess isocyanates, which when applied, reacts with the moisture in the atmosphere to form tough coating films under ambient conditions. They have excellent resistance to abrasion and hence used as floor coatings. The prepolymer is prepared as follows. A combination of triol and diol polyethers properly chosen to provide optimum hardness and elongation are cooked with a diisocyanate at high temperatures in a nitrogen-blanketed kettle and water-free solvents. The prepolymer has excess of isocyanate NCO groups, which react with the moisture in the atmosphere to provide hard, tough abrasion-resistant dry films by solvent evaporation and cross-linking to high polymers. Polyethers widely used here are diols and triols of propylene oxide. Other polyethers employed are random or block copolymers of tetrahydrofuran and alkaline oxide. Isocyanates used are the diisocyanates TDI, HMDI, MDI or IPDI. These moisture-curing prepolymers are generally made as unpigmented clear coatings since it is difficult to remove moisture completely from the pigments without even traces. Because NCO groups are very sensitive to moisture, the material may get gelled in the can during storage. But under careful conditions, pigmented coatings are also made. By proper choice of diols and triols, this one-component coating can be made with a wide range of properties.